A lot of in-circle problems today. Is interesting. I'll just let I be the center. Just why not? And it touches BC at point D. And AD, okay, so AD meets it. So this feels a lot like poles and polars, right? So AD meets the circle at L. Okay, we need to draw the excenter. So we have the AX center. Let's see. But you know what? This problem looks kind of familiar, actually. We might have done this one too. So M is the midpoint of BC. And then, okay, we need to draw the X center. X circles always take a long time to draw. So I'll draw the two angle bisectors. Really three, but just to make it look nice. Then also AI. Well, first I'll just draw the X center. So that point L keeps disappearing and reappearing. There we go. So this will be K. EC, okay, N is the midpoint of KM. It's interesting. Is KM parallel to ID? It almost looks like it, but I don't think, I would be surprised if that were true. We want to show that B, C, N, and L are cyclic. Actually, I don't think I have done this problem before. Okay. So AI and K are collinear. Probably wouldn't hurt to draw the X circle. I wish there was some GeoGebra code to just draw the X circle. Maybe there's a way to like program it in. Is it true that AD is parallel to MK? I think it might be.
It looks like it.
For what?
It looks like it.
Yeah. I think there's a simple proof of it. I just forgot what the proof is. Okay, so we want to show B, C, N, and L are cyclic. This problem looks so familiar. Let me see. So N, L, if it's true that they're parallel, then it might, oh, and L, I, and N look collinear.
That is actually not true.
Oh, really? LINN?
Yeah, on my picture doesn't look like it.
Oh, yeah. It's just, it misses it. You're right. It's tricky. Well, I'm glad I didn't just think that for a long time. Yeah, I'm pretty sure that there's like a pretty short proof that MK is parallel to AB.
It is parallel because if you draw the circumcircle of ABC,
Mhm.
yeah, and AI cut, yeah, that point is the midpoint of arc BC,
Mhm.
yeah, and
So,
OM is perpendicular to BC as well as ID. So ID is parallel to MO.
mhm.
Yeah, and if you call IO cut BC at a point, then
Okay.
use phase, yeah, and they will be parallel.
Okay.
So PD over PM is equal to PI over PO.
Mhm.
But A but AIPK is harmonic.
AIPK, yeah. So then it
Yeah,
follows that they're parallel.
yeah. So PO times PA is equal to PI times PK. That means PI over PO is equal to PI over PK, and that equal to PD over PM. So AD will parallel to MK.
All right, it's a nice one. So AD is parallel to MK for that reason. So showing that, let's see, we want to show that B, C, N, and L are cyclic. What if so we don't know the circle exists, but I'm going to try something. So what if we reflect L across the perpendicular bisector of BC? Well, wait, you know what? Let's draw the circumcircle of BKC because here's my, okay, yeah, BIKC is cyclic. So let's see where KM meets that circle. So let it meet it at this point. So IK is a diameter. So yeah, I'm trying to use power of a point. So we have BM times MC is KM times MQ. And then NM is half of KM. And we want to show that B, C, N, and L are cyclic. So basically, yeah, actually I should draw the circumcircle of I could just let this meet it at another point. So let's see. So I want to show that Q is the midpoint of MR, I think. Maybe it's just like the power ratio lemma or something. Yeah, I want to show that Q is the midpoint of MR. So basically, I could kind of ignore point N for the time being, and I could just look at the circumcircles of BIC and BLC, and then I want to show that M is the midpoint of QR. Or Q is the midpoint of MR. We also know IQ is perpendicular to MR, so oh, that's interesting. So basically, we just want to show IM equals IR. And we know IM bisects AD. Actually, you know what? I wonder, like, for example, I wonder if this is always like the midpoint. So like if we, no, it's not always. Now, let me just delete some stuff. I'm not sure how good of a strategy that is. Oops. Actually, let me think about it for one more second.
Sorry, Michael.
How what?
Maybe we will prove RL is tangent to I, whose is equal I.
RL is tangent to the in circle?
Yes.
Ah. Wait, I wonder. Oh, because basically, is this an isosceles trapezoid right here? I think so, right? Or we want to show it's an isosceles trapezoid, right? And then we would have IM equals IR, and then that would solve the problem. So basically, we could rephrase the problem. Let R be the point so that RLDM is an isosceles trapezoid. Then we want to show that BLRC is cyclic. I think that would solve it. So can we say anything? Can we show that angle BLC would be BRC? But yeah, that does seem like a simple problem, right? You just want to let R be the point such that RLDM is an isosceles trapezoid, and then you want to show BLRC is cyclic.
I think I have finished this problem.
Okay.
So let the integral E tangent to AB and AC to 2 points.
Okay.
You can call the name. And let SC intersect BC at 1 point.
So okay. So yeah, that's going to be concurrent with the tangent at L, but we don't know that it passes through R yet.
Yes. Before that, I will denote. I will let UL intersect BLC again at R prime.
Okay.
So we need to prove that R prime MK are collinear.
Okay. So I'm going to hide this. Sorry. Let me hide it for a second. Whoops, I got to hide it again. Okay.
So we all know that UDBC is isogonal conjugate.
Okay.
So UD times UN is equal to UB times UC equal to UL times UR prime.
Okay, so UB times UC is UL times UR prime.
And R SDT is harmonic quadrilateral. So UL is equal to UD, right?
Mm-hmm. Yes.
So that L U R prime equal to UM, and we have LDM R prime is a trapezoid, an isosceles trapezoid.
Trapezoid. Okay.
So we have LD parallel to M R prime.
And we know MK is parallel to AB. So from what Dat said. So then that solves it. All right. So I'm gonna write this up. I like this. Nice solution. Okay. Okay, so let ST meet BC at point U. So let S and T be the tangents of the inner circle to AB and AC. Oops, sorry, bad. AB and AC. And let ST meet BC at U. Then, so since U lies on the polar of A lies on the polar of U. So and that means that UL is tangent to the inner circle. And let UL meet the circumcircle BLC at R prime. Whoops. And then, so we have U, B, D, and C are harmonic. Or I'll just say B, C, D, U are harmonic. And so that means that okay, so UL is equal to UD, but we have UL times UR prime is UB times UC, which is UD. Okay, so that means that UB times UC is UD times UM. And that's UL times UR prime. So yes, so but UL equals UD, so R prime equals UM. And so once we know that, that means that LD is parallel to R prime M. Since it's an isosceles trapezoid. So, but then we know AD is parallel to KM from what Feng was saying, because sorry, because OM is parallel to ID, and AP over PI is KP over OP. So okay, so I think there was an even simpler way to see that, to prove that. I just don't remember it now. but I'll just write that out. So let AI meet ABC at O. This proof's good enough for now. And then OM is parallel to IB. And then we also have AI. So it's not hard to show that so AI, O, and K are in harmonic conjugation, right? So I'll just write I'll just say that implies that AD is parallel to KM. Or I'll just say LD. I'll say 80. And so then that implies R prime, M and K are collinear. So, and then well, now we use power of a point a bunch of times, I think, right? Because basically Q is the midpoint of RM. So since IQ is perpendicular to QK, that means Q is the midpoint of R prime M, I think it was, right? Midpoint. So that's true by symmetry. And then we have BM times MC is QM times MK. So yeah, now it's just power of a point because BM times MC is QM times MK, which is R prime M times MN, where N is, so that's R prime M times MN. And that that means that B CNLR prime is cyclic, and that solves it. All right. So that is a very nice solution. And I will move on to the next one. All right, thanks for that. So we have about an hour left. This problem looks a little bit long. So you have a triangle ABC. Sometimes the long ones aren't as hard though. Sometimes they trick you. So you have a triangle ABC. M is the midpoint of BC. Let me check who we still have on. Oh, it looks like Serdar had to hop off. So M is the midpoint of BC. And AM meets it at R. And then we draw a line through R parallel to BC. So it looks like symmedians. Whenever I see this, I often think of symmedians. I see AM all disjoined. So this meets the circumcircle at S. U is the foot of the perpendicular from R to BC. Hey, Amal, thanks for joining. So this is U. Okay, so BSRC is an isosceles trapezoid. T is the reflection of U over R. Okay, so that's off the page. Let me shrink stuff a little bit. Oh, you can see it. So that should be T. But yeah, whenever there's midpoints, I always think symmedians. So we'll see if that works. D lies on, so AD is the altitude. And N is the midpoint of AD. So let's see. See, someone wrote something in the chat. Oh yeah, Happy New Year, Amal. He just messaged me privately. So that's N. Yeah, I hope you all had a good New Year. I had fun. AS and MN meet at K. And we want to show that AT bisects MK. It's kind of random, but so it feels maybe a little like projective geometry here. I'm just going to draw the intersection point. We want to show that ME is EK. Oops. What was U? Oh, U was the perpendicular from R to BC. All right, so what happens if we try to use projective geometry? We project through A onto the circle, let's say.
K should be the symmedian point of the triangle.
Oh, really?
Yeah. I don't know the proof of it, but like I've seen that in the Avanchan's book.
Interesting. Okay.
Yeah,
So,
K will be the lemonade point. K will be a lemonade point of triangle ABC.
can I do what?
The lemon, you know, it is the
Symmedian point?
intersection of three symmedian.
Okay. Let's see. Oh yeah, I've seen that the symmedian point lies on MN. I think there's a name for that lemma. I forgot what it's called. Is that the Schwatt line? I think it's the Schwatt line, right? So I'll type that in the chat. Oh, whoops, sorry, I just messaged Amal directly. Yeah, the Schwatt line. So I know the symmedian point lies on MN. But, oh, and AS is a symmedian because it's the reflection of AM over, because angle BAS is angle CAR. So yeah, K is the symmedian point. We want to show that AT bisects MK. Or we could take K, E, and M and project them onto the circle. So we'd get RFS, and then we'd have to draw the parallel. Maybe there's a better way. Yeah, maybe we could do N, K, E, and M instead. That looks a little better because, yeah, if we project M, K, E, and N onto the circle, then we get G, S, F, and R. Are G, S, and T collinear? No. So yeah, K is the symmedian point. So yeah, we could draw the other symmedians too, if we want. Is SFRC harmonic? Let's see. So if I draw the tangents, and then I draw FC, I don't think so. It's close, but like if A is like right there, it doesn't look harmonic. Yeah. So yeah, AS is a symmedian. I'll just draw RS. I feel like it just helps me visually. So I draw this point right here. Like maybe I could project KEM. So MN, oh no. What if I projected through A onto UT? So KEM, yeah, what if I project KEM and N through A onto UT? So we'd get RT and then some point really far away. Oh, you know what? So basically, yeah, let AS meet UT at a point. Let me see if I can make the diagram better. It's almost like I want R and S to, it's really hard to make AS intersect UT. The diagram just doesn't want to do it. Unless it's like, unless it's like that. Maybe I should just draw it. I'm gonna try to do it, try my best. Okay, if AS intersects UT, look at how crazy that is. So basically the cross ratio NKEM, if I project through A onto UT, that would be HT R infinity. So I want to show like I think HT over TR is equal to NK over NM. Is that what I have to show? Or, no, HT over TR is MK over KN. And I wonder if those triangles are similar. Well, yeah. So is A and M similar to HRA? Oh, no, I don't think so, actually. Let me check something. No. So yeah, do we want to use that K as the symmedian point somehow? I'm just not sure how to do it. So RT over RH is the same as RU over RH. I wonder if R is the orthocenter of BCH. So wait a sec. We know K is the symmedian point. So we could draw these tangents.
If we take the DK to intersect AT.
DK?
Yes, DK intersect AT.
Okay.
Then that intersection point and U, that line, is parallel to NM.
Okay.
I mean, that is sufficient and looks like true.
So JU is parallel to MN?
Looks like it, yes.
Okay.
And by some projections, it is actually sufficient.
Okay. Okay, so I will just draw dj. Okay, so if we could show JU is parallel to MN, that solves the problem. Is I the midpoint of HS? That almost looks like it's the case. Yeah. Oh, is that obvious actually? I think that's obvious. Yeah. So I is the midpoint of HS. Does UR equal RT? Yes, that's true by definition because T is the reflection of U over R. How is because basically, so we mentioned that K basically K lies on the symmedian, so AK passes through I, where I is the intersection of the tangents, and then R and S are symmetric about the perpendicular bisector BC because that's kind of just how it's defined because RS is parallel to BC and I is obviously symmetric with respect to B and C. And angle RSH is a right angle. So I has to be the midpoint of HS. Sorry. So HTR yeah, we have a couple different ways of doing this. So HR over TR is the same as HR over RU. I wonder if that does it. Because like if I draw AU, okay, I don't think this is true, but I wanted to check if yeah, there's no way that's true. 149. Can I draw a line through N parallel to BC? Yes. So yeah, maybe you want to see if those concur. Let's see. I don't think there's a concurrence.
NR, AT, and BC concur.
NR, AT, and BC. Okay.
And I have actually proved it.
Okay. Yeah, walk us through how you did it.
AD and UT are parallel. That is
Okay.
obvious by definition.
Mhm.
And N is midpoint of AD and R is midpoint of UT.
Mhm.
So then if we intersect DT and AU, then we will make
DT and AU?
Yes, and then that will actually be Cheva's theorem.
Okay. So I'm going to delete some of the other stuff I added because I don't think your solution, I don't think uses point I, right?
I mean, I'm not, I didn't solve the entire problem, but just that.
Oh, okay. So I'll add it back then. But so you were saying with point L, oh, you're saying by Cheva's theorem, these concur. Yeah.
Yeah.
Yeah, because we have two midpoints like that. So okay. So triangle ART is similar, or so ARH is similar to ANK. I wonder if AUR is similar to something. No, ARH is not similar to ANK, I don't think. So yeah, I'm going to delete point L, but I see how you did that. So yeah, you show that they concur. So if you could show JU is parallel to MN, you said that solves it?
Yeah.
Okay. Let's move this up a tiny bit. There we go. But OM, is FM perpendicular to, no, I don't think it can be. Check the chat. I'm not sure actually.
I can explain the reasoning behind that.
Okay.
So we will project we have points T, R, U, and A, and we want to project through A to BC.
Okay.
And the point of infinity goes to D because AD and TU are parallel.
Okay,
And,
so you're doing T, R, U, and H. Are those the points you said?
No, T, R, U, and the point of infinity.
Okay.
So like they will be in harmonic conjugation, and when we project, they will project to DM OU.
Okay.
And then if J U is parallel, then if we project to J to MN, then actually E will be the midpoint of KM because U would go to the point of infinity.
Ah, nice.
So that is why it is sufficient.
Okay, that makes sense. Yeah, and I like how that uses the fact that R is the midpoint of TU. So you're using that fact there. Okay, so since K is the symmedian point, yeah, how do we use that fact? So we could just say, because yeah, J is where DK intersects AF. So yeah, can we show JE over EO is OM over MU? Let's see. Are AK and AM isogonal? Yes, they are isogonal. Maybe we could also show DM over DU is DK over DJ. Kind of like that. So yeah, maybe we could project DK and J and then D, M, and U onto the circle and show that. So we could do DKJ infinity and DMU infinity. But yeah, the thing is we would need to draw like the parallel from A to DJ. I'm not sure if that would help. Let's check the chat. So AKM would be isosceles. Really? AKM? Maybe you meant something else. They're isogonal, AK and AM, but I don't think there's isosceles triangles.
Maybe we can project through N somewhere, because we have proved that NR and O are collinear. So like project DMOU somewhere, like I don't know where, but somewhere.
Okay.
Through N.
DMO and U. Yeah, it's tricky. I just don't, we have to use that K lies on, okay, so K we could just say is like the intersection of AI with MN. So triangle ANK is similar to MKI. Maybe we could use that ratio. So we have AN over NK is KM over MI. And do you guys want to just check out the next problem? Just see. I'm just going to check it out. What it looks like. Oh, this looks like it might be kind of easy. Let's see if we can do this one. And then we can return to that last one. So we have a triangle with incenter I and circumcenter O. All right, we draw the incenter. And L is drawn parallel to BC and tangent to the incircle. So basically, this line, and it intersects IO at X. Let's see. So that's X, and can select Y on L such that YI is perpendicular to IO. Okay, so you want to draw the perpendicular line. Oh, this problem feels so familiar. I feel like we've done this before. Y. So we want to show AXOY is cyclic. Interesting. Okay. Yeah, I'm almost sure we've done this problem before. Okay, so what's the best way to do this? I don't think it was that long of a proof either. So what do we see if we draw that circle? Maybe extend ID to meet the circle at another point. I feel like that helps sometimes. Is there anything special about that point? Oops, sorry. Or we could try to see where a yi meets the circle and maybe use power of a point. It's yi, I don't think, yeah, it's not the radical axis. I don't think OX is a diameter of that circle, but I'm not sure. Just trying a bunch of stuff here. So we know it's maybe worth drawing AE just because we know that if we let it meet BC at a point, then D and C are reflections across the midpoint of BC, or D in that point. And this is also a right angle right here. I don't know if that helps. Just trying different things. Okay, so we know that IE squared is XE times EY, right? I think that's part of the solution. So IE squared is XE times EY. And basically, what happens if we draw the circumcircle of XAYO? If we let it meet it at a point, basically we want to show IE squared is AE times EH. But yeah, how would we define 8? We could, we have to use O somehow. So basically, we could let the circumcircle of AXY cut, well, yeah, like I wonder if it's easiest to like show that. Yeah, I'm just trying to think the best way to do this. No, that doesn't pass through G. So what can we say about AE times AH? Because AE is kind of like proportional to AF if you use ratios. Where do we use O? Yeah, I was trying to use power of a point. So if we have IE squared is AE times EH, what does that tell us? Like, what if we drew perpendicular? So yeah, I'm just trying to think how to convert that condition. So IE squared is the same as IE times ID. And that's AE times EH. So basically, I mean, if we shift, what if we shifted A and H downward? So like what if we did like okay, let me try this. So so I'm going to shift A downwards. And then I'm going to shift H downwards. So okay, so E prime, so these three should be collinear. I call them A prime, I, and H prime. And then these are cyclic. And then basically I want to show, is that the same size as the circumcircle of AXOY? No, it's not. Okay, so that kind of, all right. I'm going to go back to the last problem just for a second. But yeah, we're almost out of time. This is a hard day.
It's sufficient to prove that AM over MR is equal to DK or KJ.
AM over MR is DK over KJ.
It is sufficient to prove.
Okay. So we want to show yeah, it's so hard to get that. Can we use like reflections kind of? So let's draw maybe draw the center of the circle. So we never use that really, the center of the circle. So AD and AL are isogonal, and then AK and AM are isogonal. So yeah, like maybe like does DK over DJ equal so we have M and yeah, the thing is I don't know where J reflects to. So I don't know what the symmetric of J would be. Let's see who's on. All right, I think I'm gonna stop here. So thanks everyone for participating, and for everyone on YouTube, thanks for watching. If you would like to participate in future sessions, feel free to email me at mgreenb801@gmail.com. They're on Sundays at 8 a.m. US Central Time. So this was a really hard set of problems today. We only solved 2, but I feel like we still made good progress on a couple others. So that's still a good note. But after this time, I'm probably going to be doing more problems not on the Taiwan team selection test. So I find that this is a really hard competition. So who knows, maybe the next one will be a little bit easier. So thanks for watching, and have a good day.